Hey everyone, this is Aishwarya. In this video, I'll be explaining the chapter 7 quantitative process analysis. So, what is quantitative process analysis? It is basically a way of using numbers and measurements to evaluate how well business processes work. It looks at specific metrics like how long a particular task takes, how much they cost, how much work gets done, and how resources are used. These numbers help identify any areas where work is slowing down and show where improvements can be made. By analyzing this kind of data, organizations can make smarter decisions, better decisions on how to improve processes, allocate resources better, and ultimately save time and money. So let's just look at one situation. Say the process owner of a company called Build It wants to convince the CEO to buy tablets for all the site engineers. These tablets would allow engineers to look at supplier catalogs and make or update rental requests from any construction site, making their work easier and quicker. But to get the CEO on board, like to get him convinced, the process owner just can't say yes, this was going to be very helpful. They need to prove with the numbers how much time, effort, and money the tablets will save. uh, so why is this quantitative analysis necessary? Just let's take like qualitative analysis is basically useful for understanding the situation, but it's not enough. Like the situation that we considered previously, the CEO needs hard data, like how much fast things will be or how much money will be saved. This is where the quantitative analysis comes in, giving measurable performance metrics like as it is mentioned here, cycle time, waiting time, cost. So how long it takes to complete a process from the beginning till the end is the cycle time. Waiting time, how much time is spent for spent waiting for a task or service. Cost, how much the process costs to complete. So this is done by three techniques to analyze this performance. It is called flow analysis, queuing analysis, and simulation. So in the flow analysis, it just speaks about how work flows through a process. So for the previous example, the process owner could show that giving tablets will reduce the time needed to place rental orders, improving the speed of the process. But in queuing analysis, uh, this particular technique helps identify waiting times and bottlenecks in the process. So, like for the Build It company, engineers may have to wait for office staff to place their orders. If they can use tablets, waiting times will go down since they cannot do it themselves. And the last technique, simulation, it creates a virtual model of the process to test how different scenarios will play out. So for the previous example, Build It company, the process owner could simulate what would happen like if the company gave tablets to all engineers, showing the impact on speed and the cost savings. Now let us look at each of these techniques one by one. What is this flow analysis? It's basically a method for evaluating the overall performance of a process by analyzing each individual task. It involves calculating metrics like how we discussed previously, cycle time, cost, error rate, and all those. So, coming to calculating cycle time using flow analysis. To calculate cycle time using flow analysis, we basically add up the average times of each task in the process, considering all possible paths. So, if there's a decision point, we factor in the probability of each path being chosen. So, as the steps mentioned here, for example, like identify each task's cycle time. First, identifying the cycle time. Then consider decision gateways using the XOR splits or the OR splits to account for different paths. Then what is done is multiply each path cycle time by its probability and then later add them up. This gives the overall average cycle time for the entire process. Then speaking about the cycle time efficiency, this basically measures how efficiently a process is running by comparing the actual time spent on productive tasks to the total cycle time. So this is like it's given by value added time divided by the total cycle time. A higher CTE means that the process is more efficient with less delays or less wastage. Then coming to the critical path. Basically, it is a technique to identify the longest sequence a task takes for a project or for the entire project to get over. So it determines the critical path of tasks that must stay on the schedule, helps ensure the entire path finishes on time, and uh, it mainly the essential thing is that with minimal or no flexibility it pinpoints that point, so estimates the project duration by analyzing task dependencies. Okay, so next is the Little's law. Little's law, this formula is used in operations and queuing theory to relate three uh, key metrics of a system. So we say L is equals to lambda times W, where L is average number of items that is in the system. Lambda is the average arrival rate of items into the system. W is average time each item spends in the systems. And now coming to the capacity and bottlenecks. What is this capacity? It is the maximum output a process can produce in a given time in a given time period. So it reflects how much a system can handle efficiently. And bottlenecks is it is one stage in a process that has the lowest capacity. It has the lowest capacity. I It's basically the opposite of capacity bottleneck, slowing down the entire workflow since a bottleneck limits the overall output. Identifying and improving bottleneck becomes a very essential becomes a very essential part of the business process to increase its system's capacity and efficiency. So, in a business process, capacity reflects how much work a department or team can handle efficiently, whereas in bottleneck maybe to a specific task, department, or resource that limits overall process efficiency. Now going to the next topic, flow analysis for cost. So this basically calculates the cost uh, for a total process. So flow analysis for cost calculates the total cost of a process by summing up the each individual task. Each individual task cost is added up and we get the total cost. So each task cost is multiplied by how often it occurs in the process, and any decision points are factored in with their probabilities. This helps in understanding where costs are concentrated and identifying opportunities to reduce expenses. Then there are few drawbacks in this techniques. So just to mention a few, simplicity, it assumes average values and probabilities which may not actually reflect real life variability. Static view, it doesn't account for changes over time like shifts in demand or unexpected delays. Sequential focus. Basically, it works best for the linear processes, making it less effective for complex or interconnected workflows. Okay, so coming to the next technique that is queues. Queues are basically an essential waiting lines that form whenever the demand for a service or a task exceeds the resource available to handle them. This usually happens in scenarios where there are more tasks or customers than the system can immediately process, causing like items or even people to wait until resources are like completely free. Queues can develop in any part of a business process, whether it's customers waiting at a checkout, or documents waiting to be approved, or even jobs waiting in a manufacturing line. So, the basically queuing theory is a system that consists of one or more queues and servers that handle tasks or customers. There are two main types of queuing systems. It is called as a multi-line and the single line. Multi-line systems like in supermarkets where each line has their own server. And when it comes speaking about the single line, it systems like banks where one queue leads to multiple servers. So there are two common models that are used in queues. It is called as MM1 as mentioned. Uh, it is it is a single server with exponentially distributed arrival and service time. It follows the first in, first out, the FIFO rule, first in, first out. And the MMC, that is similar to MM1 but with multiple servers. The C is called as the servers there. So it follows multiple servers, and it also serves the FIFO basis with customers served by any available server. This also follows the first in, first out rule. Okay, so coming to the last technique mentioned in the chapter, simulation. So, what is this simulation? It is a way, it is some kind of study on understanding how a process works by creating a virtual model of it. Like something is done virtually in order for a person to understand it better. Think of it as like setting up a practice run or a test version of the process. Instead of testing with real tasks or customers, this simulation uses pretend cases, running them through each step of the process, just as if it were happening in real life. At each step, the simulator collects information like how long each step takes or where those delays can happen in those particular steps. So this produces two types of outputs, as it is mentioned there: simulation logs and statistical results. So simulation logs detailed records of each step in the simulated process. Statistical results is key performance data such as average cycle time, waiting time, and resource utilization. Speaking about the input for process simulation, to run a process simulation, several details like must be defined for each task, like processing, time distribution, performance attributes, resource pool. So, what is processing time distribution? Types like fixed exponential or normal distributions are chosen based on the task characteristics. Performance attributes is cost and value added specifics for each task. Resource pool is like where which resources will handle the task, including pool size and cost per unit time if available. Moving to the simulation tools, uh, all all the tools mentioned like uh, ARIS, IBM BPM, all these are the business process modeling tools. Uh, they offer simulation features to analyze process performance. So, like the the key key differences and functionalities found across these tools are like are mentioned here: calendars for resources, branching conditions, arrival settings, resource pool, and cost. So, what is this calendar for resources? It is some tools like allow setting work schedules so resources only work during specific hours, like business hours only. Branching conditions, advanced tools can use Boolean expressions to define specific conditions for decisions. Example, loan amounts, directing workflow paths. Then arrival settings is tools vary in arrival settings, letting users specify either an average arrival rate or inter arrival time. And like in some cases it can enable batch arrivals, like for example processing large documents batches annually. And lastly, speaking about the resource pools and costs, simple tools set a single cost for a resource pool while other allow detailed customization on them with specific cost for each resource. So these are all the tools that is used in quantitative process analysis. Thank you.